How's everybody doing out there? Hopefully, everybody did a good job with our probability distribution functions. And so, in this section, we're still going to use our probability distribution functions, but we're going to be finding the mean or expected value of this and also the standard deviation of a probability distribution function. And so, the nice thing is with the expected value, so this is giving us an idea of what the long term or the average of some probability distribution function might be. So this gets used by like insurance companies, for example, if they're trying to figure out what to charge, type people for their insurance services. Gambling institutions use this as a way to figure out, what they should set the games at, because in the end, ultimately, both of these places want to make money, and so they want to make sure that they're charging enough on the front end to cover any kind of, losses that they could possibly take. So if we look at our formula for expected value or for mean, so notice first off we're using mu of x. So what we're dealing with is a population mean, because in this case we know all the data. There's not a sample or anything. And what we're going to do is take our little x, our data values, and then multiply them by the probability. And then this is our sum, so we're just going to add those all together. And that gives us our expected value, our average. All right, so let's take a look at an example real quick here. So for this one, we've got the probability distribution function where this is represented by the earnings on some kind of investment. So we've got our zero, or a chance of breaking even, is going to be a 40% chance. A chance of making $10,000 is going to be a 20% chance. A chance of making $50,000 is going to be a 15% chance. And then we have a 25% chance of losing $20,000. So that's what the negative means for that. So if we lay this out, we're going to get our mu of x, or e of x is going to take, so we're going to take the 0 multiplied by 0.4, take the 10,000 multiplied by 0.2, take the 50,000 multiplied by 0.15, and then finally minus 20,000 times our 0.25. And then if we just throw this in the calculator exactly the way it is, we'll see that we get 4,500 for this. So what we would expect to make in the long run is we'd expect, on our investment to make about $4,500. So that's pretty good. Again, there could be some ups and downs where you'll make more here and there, but overall, between losses and gains, you'll still end up at a positive 4,500, which is probably worth investing in. All right, so let's take a look at example 2. So suppose we propose a certain game to play. So the game, you pay $1 up front, you roll a fair 6-sided die. If a 1, 2, or 3 comes up, we lose. If a 4 or a 5 comes up, we win $1. And if a 6 comes up, we win $3. And so it's asking, should we play this game or not? So with this one, the x's that we're looking at is our kind of net loss or net gain that we're going to get off of this game. So it has nothing to do with the die rolls. That's actually going to come in for our probabilities. So in this case, our little x is going to be, in the first case, if we roll a 1, 2, or 3, we lose the $1 that we had given them. So in this case, we're at a -1. So for a 4 or 5, when it says we win $1, that just means we get the exact same dollar back. So we gave them $1, they gave us $1 back, so we just break even. And then if a 6 comes up, we win $3, but remember we gave them $1 originally, so we end up just winning $2 in that case. So our possible outcomes are going to be -1, 0, and 2. So we'll go and fill those out on our chart. And so now this is where the die rolls are going to come in terms of our probability. So since we're rolling a 6-sided die, if we roll a 1, 2, or a 3, then we've got 3 chances of that number occurring, or one of those numbers occurring, out of 6. If a 4 or a 5 comes up, there's 2 ways that could occur out of 6. And then finally the last one, if a 6 comes up, there's only one way a 6 can come up, so we're going to get 1/6. So our expected value for this game is going to be -1 times our 3/6 plus 0 times our 2/6 plus 2 times our 1/6. And then simplifying this, -1 times 3/6 is just going to be -3/6. 0 times 2/6 is just going to be 0. And then 2 times 1/6 is going to be 2/6. And so if we subtract, we're going to get -1/6, which is approximately about 17 cents negative. So again, and the fact that we're going to lose 17 cents, even though it doesn't sound like a lot, so this would definitely be a game we probably wouldn't be too interested in winning or playing. Again, now that doesn't mean you won't win some and lose some, or you could get up some at some point in time. But overall, if you played this game 1,000 times or 100 times or 1,000,000 times or something like that, eventually we would see that it would sort of level out and we'd be losing around 17 cents on average. All right, perfect. So let's try practice 1 and practice 2, and then we'll come back and talk about the standard deviation in the next video. So good luck.